Practice solutions for test unit 6, graphing linear equations, part 1. So you have to be able to determine and compare characteristics of functions, slope, the x and y intercepts. You have to have a graph, different types of functions, and you have to be able to use the slope-intercept form. So number 1, which table of values and graph pair represent the equation y equals negative 6x? All right, well, we can look at all of these points and try to match. But first of all, we know that the slope is negative 6x, and we know that there's no y-intercept. So instead of doing each function, I'm going to look for that. So when x is 0, I have my y-intercept, and it has to be 0. So here's x is 0, y is 0. So that's good. X is 0, y is 0. That's good. Same thing there. So all of them have the same y-intercept. So now we have to do slope. So I find the difference here. I'm getting larger, so it's positive 6. Here I'm getting larger, positive 1. 6 over 1 is 6. I need negative 6. Okay? Here I'm getting smaller, negative 6. Here I'm getting larger, positive 1. So I have negative 6 over 1, which is negative 6. So this could be it. So let's look at our points. Over negative 1, up 6, 0, 0. Over 1, down 6, that matches. Number 2, graph the equation. Well, this is a special equation. Remember, there is no x coordinate. So that means that y equals negative 8 would be that type of graph. Remember, I have negative 8, negative 8, negative 8. So in your notes, you have to remember what kind that was. Well, if I have negative 8, that means every single point would be negative 8 for the y coordinate. So that would be up here, no, and right there. Okay? So in this case, it's this one. Every single coordinate is up 8. 1, 8, 2, 8, 3, 8, negative 5, 8. So all of them are negative 8. So that would be your answer. So here we have to graph the equation. 6x minus 12 equals 0. So one thing you should notice is there is no y there. So if there is no y, this question is kind of like this question. You're going to have an x equals. Here you had a y equals. You know that it was a horizontal line. And horizontal lines have a slope of 0, right? Well, in this question, I'm only going to have an x left. It's going to be x equal to something. So you remember what kind of line that was? Obviously, it's the opposite of a horizontal line. It's going to be a vertical line. And your slope here would be undefined, even though they're not asking you for it. So which one of these equations has a vertical line? And it would be this one right here. Now, if we were to solve it, 6x minus 12 equals 0. This is just like our unit 5. Okay, same change opposite. I'm going to add 12 to each side. They cancel, and up to 6x equals 12. I'm going to divide by 6. This is just a two-step equation. X equals 2. So notice every single x coordinate would be 2. There's 10, 2, 9, 2, 3, 2, negative 4, 2. So those are your special equations. Y equals 2x. Well, this isn't slope-intercept form. Y equals mx plus b. I just don't have plus b, so it would be plus 0. So I know it has to go through the origin, and they all do. So they're all still correct. I know the slope is 2 over 1. It's positive. This is a negative slope up and to the left, so that's not right. This is a negative slope up and to the left. That's not right. Both of these are positive, so I go up 2 and over 1. Up 2 over 1, up 2 over 1, whereas this one is up 1 over 2. So that can't be it, so our answer is B. State the x and y intercepts of the line with the equation 2x minus 4. Automatically, this is in slope-intercept form. So I know that this is my y-intercept. So I do my same change opposite. So the y-intercept is negative 4, and that's the only one right here. If there were two of them that had negative 4, remember, we substitute 0 for x to find the y-intercept. That's why on our table, we always have 0 in there, no matter what this pattern is. But when I need to find the y or the x-intercept, I would substitute 0 in. So in this case, 0 equals 2x plus negative 4. So I'm going to get the x by itself, so positive 4 on both sides. So I'm left with my 2x equals 4, divide by 2, and x equals 2, which of course is right there. Number 6, find the slope of the line passing through the points -7, -8, and 9, 2. So we have two methods to do this. One is our slope formula. Y minus y, which is the difference of the y's, x minus x, which is the difference of the x's. So I can just simply substitute these points in. We have to do them in the same order. So I have my y's, -8, minus 2. And I have my x's, -7, minus 9. Do your same change opposite, and do your calculation correctly. That's -10. That's -16. I know a negative divided by negative is a positive. And then that's a fraction, less than 1, so I can simplify. 2 goes in there 5, 2 goes in there 8, so the slope is 5/8, which is actually off the screen a little bit over here. Now the other method was to make a function table and put these coordinates in the function table and then find the slope the way we learned here, which is just find the difference between y minus y, x minus x. So that's really all you're doing, okay? You're taking this, y minus y, x minus x in the formula, and you're just writing it a different way, like that. So now I'm going to subtract my x side coordinates going up and down versus in the formula left to right. That's all that you're doing. Okay? So in this case, going bigger, so it's positive, there's a difference of 10. Going bigger, so it's positive, there's a difference of 16. Rise over run, and I get the same slope. Determine the slope here. Well, this is a special equation right here. Right? Or a special slope because it's a vertical line. We know that every single one of these points has the same x coordinate. So actually the equation is x equals 1, 2, -3. So what's the slope of a line that's vertical? Undefined, and you have that in your notes. Which graph below would match the situation described? So I'm traveling 40 miles an hour, slows to 30 in the first 5 seconds. It maintains that speed for the next 5 seconds and then slows more in the next 5. All right, well, let's look at our graphs. Okay, right here is speed. Right here is time. So right here off the bat, this car starts at 30 miles an hour, maintains the same speed, then speeds up to 40, and then maintains the same speed. Well, that's not what this one said. This car starts at 40 miles an hour, so it's already running. It slows down to 30, maintains the same speed, then slows down all the way to 0, because remember, 0 is right here, and it took 15 seconds. Okay, so that's what this says. I start at 40, I slowed to 30 in the first 5 seconds. Okay, maintain that speed for another 5 seconds, and then I slowed again to a stop in the last 5. So first of all, that's 15 seconds of driving, and so we can see we ended right there. This car started at a stop, sped up to 30, stayed the same speed, then sped up to 40. This car started 30 miles an hour, sped up to 40, stayed the same, then quickly stopped down to 0. So that was our answer. So that's how you do this type of problem. Find the slope and y-intercept of the line with the equation y equals -2x plus 24. Well, we know that if a line has an equation in slope-intercept form, that m is your slope, b is your y-intercept. Okay? Well, this is in that form. Y equals -2x plus 24. So the slope is the number in front of the x, -2, and the y-intercept is the b, which is 24. This wasn't a multiple choice question. Number 10, y equals 2/5 x plus 3 is graph below. Which graph shows the result of changing the equation y equals 2/5 x plus 3 is graph below. Which graph shows the result of changing the 3 in the equation to negative 1? So my equation is in the form of slope-intercept, so I know that the 3 is the y-intercept, which obviously matches the graph. That's the whole point. What I'm going to do is I'm going to take and change the 3 in the equation to negative 1. So my new equation will be y equals 2/5 x plus negative 1. It doesn't say I'm changing my slope. So I'm going to take this point right here and I'm going to move it down to where it crosses the y-axis at negative 1. So this one would work. This one would work. This one is at 2, so that can't be it. And this y-intercept is still at 3. That can't be it. So now what I have to do is look at both of these and make sure it has the correct slope, which was 2/5. So all I got to do is match it with my original equation and make sure it's parallel, because I didn't change that. We know 2/5 is positive, so this can't be it because this is going up and to the left. This has a negative slope. Obviously this one has the same slope. They're both parallel to each other. This one has now the new y-intercept of negative 1, where this one had the old one of positive 3.